This is a very humble choice. Usually I identify as 7 people and now just 4. So I'm trying to step down a little bit, to calm down a little bit. My name is Giacomo and my pronouns are who and whom, but alternatives you can use your majesty and your majesties. Exactly, correct. Now I start with the introduction to my talk. My good friend Federico here, he noticed during my talk in Prague 1 year ago that I always take 90% of the time of my presentation for the introduction, explaining the reason I'm doing the presentation, and then the last 5 minutes with people trying to shut me down for the actual presentation. I will try to reduce the introduction time to maybe, I don't know, 70% this time, so this is a big effort for me, so please help me. Basically, this is the second version of the same presentation that Federico was criticizing in Prague 1 year ago. This presentation was announced as, actually, I rewatched this yesterday, and effectively, you really have to go like here for the start of the presentation. It's crazy. I announced that the presentation was a work in progress, that I was going to change the names, the words a lot, and so this is the second version, which I'm more satisfied with, I have to say. So what is it about? It is about money features. Basically, it's something that we learn since we are kids in school about Aristotle's features of money. The classical ones are portability, divisibility, durability, and something that we don't really discuss as Austrian, which is intrinsic value. We don't like that. But ignoring the last one, there are these classical features that when you try to reason about Bitcoin, always get a little bit confused and mixed with other new things that we have to analyze when we study Bitcoin. There are basically these ones, like we have scalability, which is a technical term that usually was used for, I don't know, data centers or it was used in completely different contexts. Scalability was how does a system react when you put some hardware in it, and how can it scale the utility if you put more hardware. And then we have fungibility, which is a typical economic term about units of money, but in Bitcoin we use fungibility somehow as a synonymous of anonymity, privacy, confidentiality, or deniability. So it's a little bit confusing. And then we have, like, instead of just durability, we have the concept that Saifedean Ammous helped to clarify in the book, in the beautiful book, The Bitcoin Standard, the concept of hard money. So durability is a very generic concept. Hard money is money that doesn't lose value over time, not just because the physical medium of the money doesn't deteriorate, but also because the production of this kind of good is not easy to inflate when the demand grows. So let's say all the consideration about the stock to flow ratio and stuff like that. And then we have something which is quite similar, which is the unforgeability and unforgeably cost, which is what Nick Szabo in another, I really suggest you to read, if you haven't, The Bitcoin Standard by Saifedean, and also the treaty Shelling Out by Nick Szabo. It's not shilling, it's shelling. Shelling Out is an altcoin treatise. It's Shelling Out, where he identified the point of unforgeably costly. What was interesting to me was to compare these features with the typical trade-offs that we see in Bitcoin. We already discussed a lot, we are nauseated by the discussion about scalability versus decentralization, and sometimes when you talk about, for example, Mimblewimble or confidential transaction, you can read developers discussing about the trade-off between perfectly hiding options versus perfectly binding options. For example, if some cryptographic assumption of Mimblewimble fail, you have to choose between having the privacy, basically, of people ruined, or the total supply unknown and impossible to derive anymore. So you have a trade-off between these. And then you have the trade-off between, for example, when you have to, imagine that you have to design a Bitcoin wallet. If you want to save fees, what you want to do is basically batching, aggregation. You want to aggregate stuff. But if you want to save privacy instead of fees, you want to do the opposite. For example, Ricochet is doing a lot of dummy transaction in between, or merge avoidance, when you don't merge your UTXO because you want more privacy. So basically, the point is that there is a trade-off between optimization of space and privacy, because you start to link stuff. So starting from these premises, I also wanted to see how this trade-off change when you analyze layer 1, so the blockchain, and layer 2, so Lightning. For example, in my previous talk in Prague, if you take a look at that, at the end of the talk I say that the Lightning Network is great because finally you can have the same level of privacy and scalability together, because Lightning Network is not obfuscation. You are not putting more data on the global layer in order to hide, but you are just retaining information from the global layer. You just it's omission, it's not obfuscation. So at the end, I say Lightning Network is great and it solves the trade-off. I don't think that's correct, because, for example, in my talk in Munich, I was analyzing the fact that in Lightning Network you have a new set of challenges about privacy. For every kind of privacy gain that you have from the fact that a chain analysis is impossible, you have a privacy loss, because now your IP address or your onion address is can be detected, and if you want to route, you have to declare the channel publicly. So you have another kind of privacy trade-off. And even the scalability trade-off is not disappeared from Lightning. For example, in Bitcoin, you have a problem when you want to send small transactions, because you have high fees potentially, but if you want to send very huge amounts, you are fine. In Lightning, you have the other way around. If you want to send microtransactions, you are basically fine, at least over the dust limit. But if you want to send $2 million on Lightning, then where the hell do you find the liquidity in the channels? That becomes a problem. So you have the opposite problem. So I finally realized that I was finishing during September and August a series of articles for Bitcoin magazine. It's called Understanding Bitcoin, because everything about Bitcoin now is named with the gerundive and Bitcoin, so something in Bitcoin. So, for example, this conference should be Transylvanian Bitcoin, and so my series is Discovering Bitcoin, actually. In this series, I identified 3 main features, and they are basically hardness, which is the same that Saifedian explained very well in the book, and darkness, which is a kind of term that I use to identify the fungibility and privacy feature of some kind of monetary instrument. And I didn't know how to call the third stuff about scalability, and I decided to use the made-up word scaleness, because it sounds kind of the same of the other. So I came out with my favorite. So I like a few things in life, my wife, of course, and I don't know, waterfalls and trees and trilemmas. I really love trilemmas. Every time I analyze a problem, I try to do a triangle about that. I can't help it. So since I ended up with 3 main features, I tried to systematize the trade-offs we were discussing about into this triangle, and I was so happy with the result on paper that I decided to share it with you, and because you don't have anything better to do. So let's analyze first the 3. I will show you the 3 features: scaleness, hardness, and darkness, with 2 variants that I think are the 2 variants that are actually important when you discuss layer 1 so the normal blockchain, and layer 2. So the first one is scaleness. When you discuss scaleness or scalability across a scale, you are actually including two different and opposite concepts. Something is more scalable if you can divide it more or if you can aggregate it more. Divisibility and let's say compactness are the two characteristics of scaleness. If you think about that, in Bitcoin on-chain, you have a problem of divisibility because what you can't do is to send very, very small amounts because the fees, the fixed fees, are so big that any amount which is smaller than the fees is not anymore economic to send. So it's a divisibility problem. While in Lightning, for example, you have a compactness problem. This is the same reason that for many years before information money, before banknotes, people were not just using gold, which is the best kind of money from the hardness point of view. They were using gold and silver. Why? Because if you want to pay for a home in silver, you need basically three caravans of silver. Silver is not compact enough to pay for a home. But if you want to pay for a coffee, then you cannot use gold, you have to use silver because otherwise you need basically a few molecules of gold, which is not very practical. So you have these two aspects of scaleness. I decided to try to divide even the other two features in two aspects. So for example, hardness is actually two different things. One aspect of hardness is what Saifedian really explores into the book, which is a global auditability of the system. So how easy it is to audit the total supply of your monetary mean in order to avoid inflationary problems or manipulation problems, so monetary-based manipulation problems. But the other part is the single personal reliability, which is a kind of security-oriented durability. So, for example, I will give the exact example, but the idea is, in Bitcoin, you have a system that makes very, very easy to know how much the total supply is or isn't changed. But for example, in Lightning, you maintain the same kind of auditability, but you lose reliability on your specific personal local asset because you can have the counterparty broadcast a old state and try to scam you, for example, with the DDoS attack or just because you are not using a watchtower. In general, a Lightning wallet is less secure personally than a on-chain address because you have to stay online, especially if you have a routing Lightning node. Basically, you are keeping your keys hot in the server, so it is inherently less secure. And the last big partition was the darkness aspect, which I divided between fungibility, which is a characteristic of the global system. So how much, so fungibility is from the point of view of the monetary unit, and deniability is from the point of view of the person using the actual system, personally speaking and locally speaking. So let's try to see where the triangle is. There are two triangles. The inner one is layer 1. And layer 1 basically offers you these three major trade-offs. The first one, okay, now there are vomit bags under your seats if you need it. We will do this kind of rotation at least 6 times, so be ready. So the first one, auditability versus divisibility. This is the typical block size war trade-off. You can have a very, very auditable system where everybody can, with very low cost, audit all the total supply, but so nobody can inflate, nobody can steal, but you have to pay for a huge, you have to reduce your block space and your block rate, and for this reason fees can be very high and they can ruin the visibility of your system. On the other hand, on the other side of the extreme, you can have a system where fees are very, very low because block space is huge, but in that case verifying and auditing the global supply becomes very, very difficult. For example, if you use the fake SPV feature, you cannot really know if the majority of miners are trying to inflate the supply, not by design at least. The second kind of trade-off is between divisibility versus fungibility, which is what I was talking before, right? So from one side, you aggregate, you do batching, but if you do batching, basically you are reducing the fungibility of coins. On the other side of the spectrum, you can use you can do merge avoidance, so you can avoid merging stuff, but then you are losing divisibility because you have to pay more fees. This can be intended in two ways. One way is just the use of the block space. So for example, if you do you want to make chain analysis difficult. So why are you just spending one UTXO and sending the output to the payee and the change address to you? Just send 3 different UTXO and 3 different fake change addresses, so nobody can actually understand which one is the change. You don't do that because you don't want to waste money on block space. You have to spend more fees if you want to create an obfuscated transaction. But there is not just the block space kind of obfuscation, there is also the cryptographic kind of obfuscation that has actually the same trade-off. Think about that. Confidential transactions or ring signatures, they are a way in which you still send all the information to anybody else, so it's still global consensus. Everybody has all the information forever, but you add even more information in order to cryptographically obfuscate the information that you are sharing. So that clearly makes basically fungibility better at the expense of divisibility, of scalability of the system. I don't know if this is clear. If we have a way to obfuscate, for example, the amount, but we need a big range proof in order to do that, we are consuming block space, so we are reducing divisibility in order to increase fungibility. And the last, this is actually upside down, is fungibility versus auditability. This is a typical trade-off we were anticipating before, hiding versus binding. If you do, for example, confidential transactions, that's fine, but if the cryptographical assumption underpinning confidential transaction are broken for some reason, then you not only you can have inflation, but you don't even know that you had inflation. This happened in a few privacy-oriented scam coins. You had some kind of hacks inside a private pool, and now you don't even know how much inflation happened and why and where and how to handle it. So the more you go toward the hiding side of the spectrum, the more you are giving up the binding part. And this is part of the reason why people is not uncontroversially okay with something like confidential transaction. It will be super cool on Bitcoin, but on one side it will reduce divisibility because it will require more block space, and on the other side it could reduce auditability of the total supply. Right now you just count numbers in order to know that there is no inflation in Bitcoin, you don't have to use any cryptographical assumption. You just count, and you can know that's true. With confidential transaction, you have to trust some kind of cryptographical assumption in order to do that. I think it was Waxwing, Adam Gibson, writing on Twitter a couple of years ago a nice story about the future Bitcoin war between the perfectly hiding side led by Peter Todd and the perfectly binding side led, I don't remember if it was Andrew Poster or anyway, the future wars will be in this trade-off according to him. So now that we finished this kind of trade-off list, let's see what happens if we analyze the outer part of the triangle, which is layer 2. What happens when we analyze Lightning? Have we completely solved the trade-offs? Are we getting any free lunch? My answer in Prague was yes. With Lightning Network, we get everything for free. And this is when something is coming for free as a general heuristic, you are wrong. If you're getting something without paying, usually there's something you're missing somewhere. Somebody is paying something. And using this general heuristic, I realized that with Lightning, we are not actually getting anything for free. We are just switching to other three kinds of trade-off in all three areas that we discussed so far. So instead of divisibility versus auditability, big block versus small block, here we have a problem of reliability versus portability. For example, we can have a super decentralized Lightning network where everybody has a very few small channels with a lot of other people, but then liquidity problems, even if we find a smart way to do multi-path atomic transaction, even if we create a smart bot that can create automatically the best liquidity path, still, if you have a very decentralized network of very small, low liquidity channels, then you have basically not a divisibility problem, but a portability problem. Now you can send $2 million in Bitcoin on-chain easily. You can't do that easily with payment channels, with Lightning. On the other side, if you have, instead of a mesh network, you have very few hubs, then the probability that the system itself is compromised, you don't have an auditability problem. Lightning hubs cannot inflate the supply, they cannot create money out of thin air, but they can affect your security directly. The specific, so if you think about taking some Bitcoins and storing them long-term for your grandchildren, if you store them in an on-chain multi-sig address, then they are pretty safe. If you store them into a channel, the more the channel is big and centralized versus a few big hubs, the more risky it is to keep money there because the specific reliability of your money there is more at risk. Because you can be, there are several ways your counterparty can trick you. Lightning is a punishment model system so far. It's not a verification model system. So it's not that the counterparty cannot steal your money. They can steal your money and you can punish them. Hopefully that works, but there can be some game theoretical situations in which it doesn't, either because you mess up with your security or because there are strange economical incentives. The second trade-off becomes basically portability versus deniability, which is a very interesting trade-off when you think about public routing channels. So if you want to optimize the liquidity, so if I want to pay $1 million on Lightning and be sure that I can find a liquidity path, what I need is a lot of real-time updated public channels. My node has to know exactly where the liquidity is in a real-time way, because if the liquidity changes in this channel, I have to know immediately so I can route in a different way. The more you have a public real-time knowledge of liquidity, the more you can scale from a liquidity point of view. But the less deniability you have, because now you have more people with in worst case scenario, an IP address. In the best case scenario, an onion address, but still some kind of static public disclosure of their liquidity. Let's assume this simple trade-off. I have a public channel with Mir, and now something is routing through me, and it's moving the balance in her direction. So what do? If I immediately update everybody about this, then I'm increasing the efficiency of the network, because people will immediately know that I don't have anymore the same capacity that I had. But if I do that, basically this is just like a chain analysis. Everybody knows in real time the state of every public channel. So I have to put some delay and some, so you still have a trade-off there. The more efficient the system is for liquidity, the less good it is for personal deniability. Of course, this is a different matter of fact that fungibility. Fungibility, again, is, so the inner triangle is about systemic property. When the fungibility is reduced, the entire system has a problem with fungibility. But when your personal deniability is reduced, it's only a problem with you. So sorry for your loss. But this is still a trade-off, but it's better, because basically you suffer directly from this trade-off. One thing that I would like to argue, I have to do the last one, and then I can argue my point in general. The last one is deniability versus reliability. For example, you have some Lightning peers, and these Lightning peers, they stop broadcast, they stop routing your transaction, they make your money stuck into an HTLC routing process. So what do? Either you keep an updated blacklist of evil peers, and you have a reputation system. But if you have a reputation system, again, you are decreasing the level of personal deniability of the system. And if you don't keep a reputation system, and you just connect with random peers, and you open your channel with people that you don't know, and you route through people that you don't know, then you are increasing the deniability of the system, because people doesn't have to public their situation, their state, but you have a problem with reliability, because you can be a target of bad peers, even in a way civil attacks and stuff like that. So my point with this is that nothing is free. The fact that we are moving to a new paradigm with a layer 2 solution doesn't mean that the classical trade-offs are disappeared. They just moved to a new level. But I will argue that, first of all, having both together is better than having just one. Two is better. So we can micromanage and adjust with a good granularity where you want one and when you want the other. And also, this outer triangle is generally better, because it actually creates a better error feedback loop. So when you are wrong and you are directly attacked because you are wrong, you learn and you suffer, you learn, and you do better the second time. But when the risk is systemic, all the players inside the system, they don't perceive the risk immediately because they are not directly affected. They are just externalizing all the risk to somebody else and to the global state of the system until it breaks down in a bad way. This is basically the classical moral hazard problem. So there is a bank in Italy, it's called Monte dei Paschi di Siena. It is the oldest bank in Italy, it's ancient, prestigious institution, and at this point, every 4 or 5 years, it's bankrupt. And since you cannot leave the poor account owners in trouble, the state steals money from other people in order to bail out the failed bank. And that's cyclical, basically. And you can imagine to be a manager of that bank. You don't really care, because if you win, you win. And if you lose, somebody else pays. And if you are, a bank account owner, it's reasonable from the personal point of view to take your money there, because you will never suffer. So it will be postponed until it failed badly in a global way. Compare that with empty GOX. If you look at the list of the GOXed people, I am in that list with 3 Bitcoin, because I was trying to do some arbitrage with the super expensive Bitcoin, and I was wrong. But nobody bailed me out when I've lost that money. I mean, maybe now there will be some kind of restitution after years, but basically I suffered, and suffering is good, because now I learned that you don't leave 3 Bitcoins on exchanges. 3.5, yeah, thanks. Thank you. 3.5 Bitcoin on exchanges. So my point is that trade-offs where the risk is local, where the de-anonymization affects you personally, so that your government or ex-husband or stalker can track you down and damage you, are better than trade-offs in which you don't suffer locally, but you just externalize the risk to the global system. So the point between small block and the point between divisibility and auditability was a very dangerous trade-off, because if we lose auditability of the system, everybody is screwed in the long run, but we don't know, we don't care, and we don't have a direct incentive to act. While the situation in which you have to select between liquidity, so basically portability in Lightning, and personal reliability is a better trade-off to have, because people can adjust to the trade-off locally, changing fast, learning and evolving. So the situation of the inner triangle is a situation where what you want is not anti-fragility. What you want on layer 1 is robustness. You want a system where you make a very conservative, cautious, super precautious and uncontroversial choices. You have to stay always on the safe side. On the outer triangle, since there is a faster feedback and shorter feedback loop, you can experiment more, and you can be wrong, and you can learn, and you can evolve, and you can fine-tune the parameters in real time. So there is a small part of the presentation in which I try to do this. So basically, I take the different kind of money during the ages. I will not really do that, so don't worry. But just to give you an idea, you have basically shells. So the typical non-metallic commodity. Then you have metal, so like gold nuggets or silver nuggets, which is better in some ways. Then you have coins, so still the metal, but now with the signature of some powerful or a reputable person certifying the amount. Then you have the banknotes, the IOUs, so the Templar Knights releasing you a paper which 3 gold nuggets written on top of it. And then there are legal tenders, which are the same kind of things than banknotes, but now they are monopolized by the government, and everybody trying to compete with that is ruled out low. Then you had fiat money, which are legal tender banknotes without any collateral anymore, after Nixon, basically. And then you have electronic fiat, which is the same stuff, but now over the internet, so where everything degenerates even faster. Then you have BP, so the Bitcoin protocol layer 1, and then you have LNP, so the Bitcoin protocol layer 2. And I tried I tried this morning to put some number about divisibility, portability, total scaleness, and auditability, reliability, total hardness, and fungibility, deniability, and total darkness. These numbers are almost random. I was just having fun. The organizers can share the Prezi with you, so you can have fun. But this is just something to represent the fact that I think that this way to frame the features in direct trade-off can be more insightful, I think, than other more confused ways. So I use this kind of experiment just to reason within myself if, for example, electronic money increased scalability a lot, because now the portability of electronic information is infinite, and the divisibility is also very high, but it decreases fungibility and deniability a lot. So I try to look at the numbers on a scale from 1 to 10, and I think that in general this is a good way to systematize the trade-offs. So what I will do in the next basically years will be to troll people on Twitter in order to adopt my division of monetary features, and nobody will follow me, so I will just go on alone. But I'm very happy of my result. If you have any question, please only respectful ones, and remember the pronouns. One there, so I give you the mic there.
Yeah, two short ones. So we were talking about ups and downs of ban lists, or like lists of peers. So Gregory Maxwell maintains a list of peers, and that gets circulated periodically. Do you want to unpack whether you think that's the ups and downs of that, and whether that's a net good or bad? And the second one was with the table, with the kind of systemization of the trade-offs of the scaleness and stuff. I have in the token space paper, I did this for moneyness, and there's a really nice kind of systematic methodology to go through and iterate all of these things. So I'll share that with you if you want to develop this further.
Oh, thank you. Thank you.
But yeah, tell me about the ban lists.
The ban list, the thing is that as is typical of the outside triangle, people will have to fine-tune between the extremes. You probably can't use this kind of peer-to-peer system without any kind of blacklist or any kind of ban list. You will need some kind of reliability, otherwise your transaction can be stuck. So probably people will adopt this kind of ban list. The more local they are, the better. So my general point is everything which is anti-fragile should be local and not global. You should never do something which is dangerous on a global level that can affect the whole system. So ban lists are probably necessary, but on a local level, on a personal level. Better if adjusted personally and without, but then you cannot, of course, prevent people from sharing, you can fine-tune incentives in a good way. The good thing about this is that when you fail, you fail on a local, even if you fail globally about the Lightning Network, even if the Lightning Network becomes really screwed up, you can still burn it down and build it again. Compared to burn down Bitcoin, that's kind of that's easy because you don't have to rebootstrap the monetary value of Bitcoin. You don't have to rebootstrap the fund distribution among people of big amounts of money, because nobody will hopefully put their life savings in Lightning channels. They will just put spending money on the Lightning channels. So you have reduced monetary losses and you don't mess up with the monetary base. So the best level is the level in which the user is directly affected by the mistake. So we are all sorry for his loss, but we can all learn. The opposite is when everybody has to bet on some kind of changes. And when we were talking about blacklists and, for example, tainted coins or Mike Hearn proposals about blacklisting people on the base layer, that's super dangerous because the whole system can be affected beyond repair. While on the upper layer, you can be more reckless in general. There? Last one. Oh, last one, okay.
Obviously, Lightning have a lot of challenge, but if you look in the future, do you see another system perfect, or you always will have a Trilemma and Trilemma again and again?
For the actual perfect system, you have to wait for my ICO and to pay me. All the non-profit free open source stuff is imperfect, unfortunately. Only my private paid system is perfect. And I think that, as we were saying before in the panel with Adam and Maxime and others, I think that so when, for example, we promote the idea of LNP BP as a comparison to the TCP IP of the internet, when you have the internet, you have the IP layer, which is just one, basically. Then when you say TCP, it's not really TCP. TCP is the most widespread protocol in a family of second layer protocol, which can be UDP and other stuff. And then the more you go up in the layer, the more you have a proliferation of alternatives. So the Bitcoin blockchain is one, but already at the second layer you have probably not just Lightning Network, but maybe you will have a couple of different Lightning Networks, because maybe you will have an L2 Lightning Network without the punishment, so with different security assumption, but with multi-party channels, and you will have a traditional DRIA-POON Lightning Network. And then you will have maybe a few state chains and a few side chains. So the second layer is called LNP, like TCP, as a concept to describe the whole, but it could be actually 3 or 4 or 5 different protocols. And then on top of that, layer 3 will probably have tens of different protocols, and so on and so on and so on. If you think about that, it's the same of the internet. One IP. TCP has a few alternatives. Then you have HTTPs that actually have a lot of alternatives. Then you have basically Facebook and Twitter that are in competition and in fast evolution. And then you have the application on top of Facebook and Twitter that are evolving even faster and with even more level of competition. So the base layer is usually convergence and stability. And the top layers is usually competition instead of convergence, and evolution instead of stability. And this is good for Bitcoin. Thank you.
All right.